Hey everyone! In this video, we're going to kind of summarize everything we've learned so far and talk about both slope-intercept form and point-slope form, mainly when to use one versus the other and how do you use them when you have the choice between the two. So still, we're going to be talking about writing equations of lines and graphing them, just kind of with this lens. So quick reminder what slope-intercept form is and then what point-slope form is. Slope-intercept form is the equation of a line, which actually I should say before we get started, both of these are different ways to write equations of lines, of linear graphs. Okay, so they're both two options. You just have to kind of choose what makes more sense in the problem that you're doing. So slope-intercept form is y equals mx plus b. Okay, that's called slope-intercept form because m is your slope and b is your y-intercept. Makes sense. Math people aren't super creative. We found kind of lame names, but it helps us remember them. Slope, intercept, this is your slope, this is your intercept. Makes sense. Okay, whereas point slope is the form when you have a point and a slope. Makes sense. So that's the one where it's you take your y variable and subtract your y coordinate, and that's equal to your slope m times the x variable minus your x coordinate. So y minus y coordinate equals slope times x minus x coordinate. So still in this one, m is your slope, which makes sense because it's called point and slope, point slope form. This y1, x1 is the coordinates of your point, or a point on the line. Of point on line. And that point would be in the form x1 comma y1, just as a reminder. Okay, so here's your slope in both of these. So they both have slope in the name. And then this one has your y-intercept, so it's called slope-intercept. This one's point slope, so it's got a point. Okay, so this should be intuitive, but just to kind of summarize, you're going to use slope-intercept form when you have a slope and a y-intercept, either given to you or easily found. Okay, so there's only one y-intercept for every graph, so you can only use that when you can find the y-intercept, or only use it easily. Whereas point slope you can use when you have slope in any other point on the line. Literally any point. Even if it's a y-intercept that's technically a point, you could still use point slope. And since there's infinitely many points on a line, there's actually more scenarios where you can use point slope than slope intercept, but they're both useful to know, so you have the option. And sometimes you like one better than the other, so that's why we're going to review both. Okay, so as in the previous videos, I kind of said, okay, we're using point slope form, let's do that for every, or we're using slope intercept form, we're using that in every problem. In these problems, you're going to have to decide which one's better to use. That's what makes this a little bit more difficult. Okay, so the question is to write the equation of the line. Then we're going to sketch a graph. So first thing you want to do is you want to look at the problem and say, what information am I given? Okay, so this criteria in problem A is I'm given m and b. Okay, just as a reminder, the m variable means slope. M stands for move. B is the y-intercept, which is where you begin graphing the line. That's what I learned at least. So when you have m and b, which form are you going to use? You have to decide. And I noticed that m and b are in this one, so I'm going to decide to use slope-intercept form. Okay, so first thing I do is I decide which one to use. Since I have m and my y-intercept, my slope and y-intercept, I'm going to use slope-intercept. Next thing I do is I write down the form of the line I want to write the equation for. So I want to use y equals mx plus b, because then you can easily plug in what you see. So m is going to go here, b is going to go here. You substitute those values in. This is not so bad. Okay, so 3/4 is m. That's going to go in front of the x always. B is -2, so you can either do plus -2 or -2. Means the same thing. But then you have your equation of your line. And if you want to sketch a graph, just as a reminder, B is where you begin. So you begin on the y-axis at your y-intercept. So we're going to find where -2 is on the y-axis. Should be somewhere like right here. You can just kind of sketch that on your own paper. And then slope tells you how to move from there. So you rise 3, run 4. So maybe that's a quick, good reminder to write down is slope is rise over run. So whatever's on top is how much you go up. Whatever's on bottom is how much you go left or right. So we're going to go up 3. 1, 2, 3. We're going to go over 4. 1, 2, 3, 4. So up 3 over 4 would be right here. And that's in the positive direction because it's positive 3/4. So our line should be increasing as we write from left to right, if we read from left to right. And there you have your line sketched. So knowing your slope, your y-intercept, you can come up with slope-intercept form and you can graph the line. Okay. As a quick reminder, I just kind of said these steps, but I want us to write them down so we have some notes on what to do when we're on our own, especially because I'm going to make you do this on your own. So first thing I want you to do is to look at the problem and decide if it's better to use point slope or slope intercept form. So basically decide which form to use based on the information you have. Okay, so you don't want to just jump into the problem. You want to take a moment to think about it. So ask yourself, do I have a point and a slope or a slope and a y-intercept? Point and slope? Or do I have slope and y-intercept? That's how you're going to decide which form to use. Okay, ask yourself that question first. Then you're going to write the general equation down, whichever one you choose. Okay, so for example, I wrote this down first. That's what I mean by write the general equation down with nothing filled in. And then you're going to fill in information. So whatever variable you have to fill in, here I filled in M and B, that would be next. Okay, 3 steps, but make sure you decide which form to use before you jump in. So I want you to try following those steps by doing part B. So you have M equals -1, and this line is going to pass through the point for -3. So ask yourself, which form should you use? Then write the general equation down. So that's going to be one of these two things, one of these two. And then you'll fill in the information. Okay, so just do that, write the equation, and I'll come back and we'll graph it together. Okay, here is what you should have done. Here's my final answer. Take a minute to look through my work as well. But I will say, first I identified that I had a slope and this was a point. So then I wrote down point slope form here because I knew that if I have a slope and a point, I'm going to use point slope form. Okay, then I color coded this. So this is my M, it goes in for M. This is my point, so it's X comma Y. So this is X1, this is Y1. And I plug them in. So X1 goes in for next to the X, Y1 goes next to the Y. Okay, but keep in mind it was Y minus your Y coordinate. So it's Y minus -3. When you subtract negative, it's actually adding. So I simplified it to get this final circle answered. Okay, if you have any questions on what I did or you did something different, you want to talk about it, please let me know. But this is what you should have done, different than the previous because we had point slope, but same kind of process. Okay, just to sketch a quick graph of this. Here's my coordinate plane. This one's a little bit different because this time you have a point. You don't have a y-intercept. But remember, y-intercept is just a point, so we can do this the same way. We're going to plot the point for -3. So this is x, we're going over 4. This is y, we're going down 3, which would be right here. Okay, instead of rising and running from my y-intercept, you're going to begin at this point. It's just a different point to start at. Your slope is -1, which is -1 over 1. So we're going to rise and run 1 in both directions, but it's got to be a negative slope, so our line needs to be decreasing. So we're going to go that way. Okay, so we went up 1 over 1, but decreasing, and that's how you'd plot that. Exact same as plotting in slope-intercept, except instead of starting at the y-intercept, you start at the point. Okay, I want you to try C again on your own, and I'll come back with the answer. Same process, so decide if you want to do point slope or slope-intercept first. Okay, then fill in your information. Okay, interestingly enough, there were 2 really good ways to do this problem. This is an example where you could have used point slope, or you could have used slope-intercept form, because I first recognized that this was a slope and this was a point, 0, 5. But if you plot that point, it's actually the y-intercept written in a different way. Because you're moving 0 on the x and up 5 on the y, it's going to be on the y-axis. So this point was also the y-intercept. So if we did point slope form, you would plug in 5 for your y-coordinate, 0 for your x-coordinate, negative 1/7 for your slope. So you'd get this. But notice if you add 5 to both sides, it's going to look just like this, right? If I move the 5 over, because negative 5 or subtract 5 and add 5 cancels each other out, that's gone, and you have negative 1/7 x plus 5, which is slope-intercept form. And I wanted to throw that in there to just show you that those are equivalent. They mean the same thing. They describe the same line, but they're in different forms. So you could have recognized that that was the y-intercept. 0, 5 is the y-intercept. Plugged in the slope is negative 1/7. Plug in the y-intercept is going to be at 5 and gotten another form of line. Either are perfectly good answers, just two ways to look at a problem. Last one should be the hardest because you will notice I don't give you a slope, right? In all the other problems, I said m is negative 1/7, m is negative 1, m is 3/4. Here, I just give you 2 points. So in order to write the equation of a line, we either need the slope and the y-intercept, which we don't have the slope, or you need a point and a slope. And we don't have the slope, so we can't write it in either of those forms. This is where your knowledge of calculating slope, all of this is going to come together. So just as a reminder, slope is rise over run. But there's an equation for that. Instead of counting on the graph, you can subtract your y-coordinates to get your rise. You can subtract your x-coordinates to get your run. So since we're reviewing this, I'm going to pause the video here. I want you to plug in values to practice calculating slope, and I'll come back with the answer in a moment. Okay, if done correctly, you might have done it backwards. We should get the same answer, that your slope is 5/3. So just as a reminder, x is listed first, then y. So I called this x1, y1, this x2, y2. So I did 6 minus 1 to subtract my y's, 2 minus negative 1 to subtract my x's. When you subtract a negative, it's actually adding, so you get 3. So that's why I got 5/3 as my slope. Okay, so from there, now you have a slope, and you have 2 different points. So if you have a point and a slope, you can use point-slope form to write the equation of your line. And the nice thing is both of these points are on the line, so it actually does not matter which point you plug in. So I could do minus y1, since I called it y1 is 6. And then my slope is 5/3. And you would do x minus your x-coordinate, which is 2, and you're done. Okay, you could also plug in negative 1 for x1. You can plug in 1 for y1. They're equivalent. It does not matter which point you pick. But I just want to show you that sometimes if you don't have the point and the slope or whatever information you need, you may have to find it. And this is where, everything we've learned comes together. Got to calculate slope, got to write the equation, doing it all. It's a hard problem because there's a lot of steps. Okay, last scenario is, what if you have a graph instead of me giving you the information? Then you have to find the information you need. So just as a reminder, for both, you need a slope. So we definitely need the m. And then you either need the y-intercept or you need the point to write it in point-slope form. So we're going to pull these things from a graph, and then we can write the equation. Slope is rise over run, so luckily we have a graph. We can just count how much we have to go up. Be careful, this goes by 2s. So this is 2, 4. We're actually going up 6. To get from 2 to 8 is 6. 8 minus 2 is 6. And then we're going over 2 units. This slope is negative because we're decreasing. So slope is rise over run. Your rise is 6. Your run is 2. It's in the negative direction, negative slope. 6 divided by 2 is actually 3. So your slope is negative 3. Okay, your B is your y-intercept, which is going to be where your line here, let's erase some of that, touches the y-axis. So that's going to be at positive 2. And if you want to write in point slope, you can pick a point. I see this blue one here. The x-coordinate is negative 2. The y-coordinate is 8. Now we have enough information to write in either point slope form or slope intercept. So I'm going to pause the video so you can try writing your own equation. You can pick either one, and I'll come back with the answer. Okay, you could choose either form, but I showed you both. So if it's slope intercept, you plug in negative 3 for the slope, 2 for your B or your y-intercept, and you're done. If it's point slope, you're plugging in negative 3 for the slope. Your y-coordinate is 8. Your x-coordinate is negative 2. But you're subtracting negatives. That's adding. Okay, but the point of this problem is you also had to find the information, but from a graph. And that's putting everything together.